Okay, hi and welcome to another DCG tutorial. So this is the first one in annotation, or with commentary. So let's see how it goes. So we're doing 2014 B-1. So it's a coordinate geometry question. So start off with the XY line and marking your coordinates. So in, up, down. So 130 is the first one. In, up 55, down 90. I tend to do them one by one so that it speeds up a bit. So 5, and down 90. Label as you go. So make sure you label as you go, alright, so you know where each individual point is. And then look at your question and join up the lamina that are connected. So you have A, B, C, D, and then you have A, B, E, F, G. So first things first, so draw the given elevation plan with two intersecting planes. So that's part A, that's it done. Determine the dihedral angle between the planes. So for the dihedral angle, you need a line section. So this question is a bit easier because the line section is given. AB is a line common to both the lamina ABCD and the lamina ABEFG. So AB therefore is your line section. So just to put it down in a different color, just so it stands out. Find the dihedral angle. You must project two auxiliary views, okay, using that line section. First view is always perpendicular to line section. Second view is always parallel to line section. So we need to go 90 degrees to this line section. So let's see, we might go out this direction off that line, alright? So what I'm going to use, I'm going to use my adjustable set square to set up that angle so that I don't need to go using my two set squares, and again it'll save you a heap of time in the exam. Alright, so perpendicular to it first. Now XY lines are always perpendicular to projection lines. So here are your projection lines. So put an XY line 90 degrees to that. And I'm going to keep it as close as I can, save a bit of room. So X1, Y1. Alright, so all those projection lines are 90 degrees to the line section. So now we're projecting from the plan. Your height must be found from the XY line back to the last view, in this case the elevation. Alright, so To save me a bit of room, I'm going to put a datum line at my first point. So G and F are the same height, so I'm going to put a datum line around that line there just to cut out that 25mm or so. That's just a reference line so that I can cut out a lot of those measurements. So our heights now are found from going from that datum line up. So in this case, G and F are actually on the line. So find F, it'll be on your XY line here. So that's F2. And G will be on it as well. So that's G2. Now, find the rest of your height. So from the datum line up to your point, alright, that's going to be the height for A, and also it's going to be the same height for D. So A is on this line here, D is on that line. So here we have A2 and D2. Next, we want the height for B and for C, and again, they're the same height. So that height will be the same height for C. So this is C and B. Make sure you're on the same lines here now. So it's B2. What's this now? This is C2. The last one then that I haven't put in yet is E. So the height for E off your datum line. That's the height for E. It's on this line here. That is E. Once you found all your points, again, join the same lamina together. So in this case you have, again, ABCD and then ABEFG. Now again, a line in section is AB, so I'm going to put that in blue again just so it stands out. Alright, so we're in perpendicular to the line intersection in the first auxiliary view. Now our second auxiliary view is going to be parallel to this line intersection. So straight up or straight down. Okay, so the line is project up parallel to the line intersection of this direction. And I'll put in my X2, Y2, and we'll put in our second auxiliary view. So parallel this angle, I'm going to use my adjustable set screw again. So set up the angle. That's my angle. Now I can project everything at that angle. So this is point E, F, G here as well. A and B will be the same point, same line. D, very close. And then C. Again, XY lines 90 degrees to your projection lines. So we have to go perpendicular to those lines, and that would be X2, Y2. Now, same thing again, you get your height from your XY line back. So if we're projecting from the auxiliary view, we have to get our height from X1, Y1 back to the plan. Now again, just say for this space, I'm going to put in a datum line. So rather than I'm going to use my adjustable set screw again. So I'm going to project that XY line back to point C for a datum line, my first point. And that gives me another datum line. Okay, so let's finish this part off now, part B. So C is on the X2, Y2, this is C3. Now get our height. So next height then up is D. So distance from the datum line to D is now your height up from X2, Y2 2 point D3. Height for A and B, similar. Datum line to A1 gives you the height there for A3. Because you're doing a point view of that line, A and B are on the same point here, so that's A3 and B3. Next we have G. So this is G up here. So this is going to be a large auxiliary view. Next point is F. That's F2. Just about enough room. F3, I should say. And then E. So this is E. Once you've found your points, the thing to remember is the lamina all stay the same. So A, B, C, D all stay joined together. A, B, E, F, G all stay joined together. Now they should be straight lines because you're doing a point view of the line section between them. So A, B is a point here, and the rest should all be in a line together. So let's join them all up. So C, D, and A, yep. And E, A, B, E, G, S. Lovely, that's all one line there. Now you can put that in strong just so it shows up, and you can mark in your dihedral angle. Okay, and that's your dihedral angle. From x2, y2 up, that was point F, E, G, and then AB, and they all join together. Same thing with AB, C, D. Alright, and there's your dihedral angle in between. Now let's move on to part C. So part C wants you to determine the true shape of the surface A, B, C, D. Now in order to do a true shape, first you need a true length. So to get a true length, we need to find one edge of the surface that is a true length. Alright. So again, nice question. CB is parallel to the XY line. And CB is parallel to the XY line again in plan. So once it's parallel to the XY line in one view, in the next view it will be a true length. So CB is a true length in either view. So if we do an auxiliary view off from CB, okay, so if we do an auxiliary view off from CB, get a point view of it, we can get the true height from the line CB to the line AD. So let's just see, might be easier to project it off here to the right. Okay, do a point view, an auxiliary view of the line CB, so project that out here. You need to project out the other line of the surface, which is AD here. You need to put in a new XY line, so we'll go with here, X1, Y1. Now if you're projecting from the elevation, then it's an auxiliary plan, so you have to get your height from the XY line down to the points in the plan. So let's see, we have loads of room, so let's just go with from the original XY line 2 point C, and that height is going to be the same for B. So this is the line CB, so mark your point here. So that gives us the point CB. Alright, now the height for AD. So the height for A, a lot larger now. Height for A going to be the same as the height for D. That is the line out there, so mark it out. Now, I need to extend my line to meet it. Move that over a bit more. So I need to extend my line out here to meet that point there. So that is the point AD. So if we are to join them together, that is now a true length of the distance, or height you could say, from CB to AD. Now to translate that back over to the elevation and draw the true shape, we need to rotate that height down to parallel to the x1, y1 and bring it across then to find our height or our true shape. Alright, so put your pin at CB, lead at AD, and rotate that height around until it's parallel to the XY line. Which is here. Project that back over to the elevation. And what you will get now is the true distance down for points A and D. So here is the point A, and here is the point D, and the lamina is still ABCD. So by joining them back, I'll keep this in green now so it stands out a bit better from the rest of the drawing. So join A back to B, B goes back over to CD, and CD are joined up, and D finishes off back to A. Okay. And if you want, you can label that then to show that it's the true shape of surface ABC. Alright, so. Okay. Now, next is part D. So another surface S on the bottle cap is a regular hexagon. Okay, so surface S, which is a regular hexagon. EF is one of the sides of the hexagon. So we'll find our point EF. So this is EF here, and it's the same in plan. EF is one of the sides of the hexagon. On a separate diagram, draw full size, the true shape of hexagon S. Alright, so if EF is one side, we need, again, just like our true shape, we need to find a true length of that side EF. So to do that, you need to rotate. No, I'm going to do it down here in plan just so it's away from this, you can see it a bit better. So we need to rotate one of the points around each other to be parallel to the XY line. And remember, if it's parallel to the XY line, it'll be true length of plan. So we'll rotate E down to be in line with F, parallel to XY line. So length from E to F then will be true length in plan. Alright, so let's use a bit of colour on this so you can see it. I'll go with blue. So bring your point F straight out. Rotate E around point F. So rotate down. And that will give you, let's say, E. And go with E1. Now, project that straight down to the plan. And repeat in plan. So we rotated E down to be parallel to the XY line from F. So if we draw a line parallel to the XY line from E to meet the line from the elevation, that will give us point E. And by joining that back to F, you have a true length of the line EF. So it said EF on another surface, on a separate diagram. So a separate diagram means I can't just use that line. So let's mark in that measurement down here somewhere. Let's start off at this point here. So that's our length. So let's mark that down here on the plan. So regular hexagon means 60 degrees. So draw on your hexagon. Question done. So there's no need to go over the elevation plan in strong. You can if you want, you have time, but there's no need to. Okay, so that was the first video I've done with commentary. Hope it helped. Please leave a like if that helped you, and if not, leave a comment. Personally, I prefer the annotation, but if the commentary is a bit better, let me know in the comments. Okay, thank you and good luck.